Hello friends, today I will discuss the servo motor. In this topic, I will discuss the necessity of its construction, principle and operation and applications. Necessity. It is a closed loop control system to control the shaft position precisely. Construction. It has several parts, DC motor or AC motor, whose shaft position is to be controlled. Gear assembly, position sensor, control circuit. Very general diagram is like this. Target position of the motor, that is shaft position of the motor, and this is the motor. Motor is driven by driver, and that driver input is nothing but output of the controller. Input to the controller is error, that is difference between the target position and the current position, and this is the encoder which converts this rotor output as current position and then sends that as the input. Next, there is another diagram which is used to explain this servo motor. This is the DC motor whose shaft position is to be controlled. So this is a gear system, and this is used for reducing the speed, shaft speed. And here this is the output to shaft, and here output shaft is connected to the potentiometer. Potentiometer means that may be any encoder or LVDT or RVDT, and that potentiometer will give the output, that is shaft output position, and that is fed to the amplifier like this. Similarly, there is a input signal to this error or amplifier, error detecting amplifier. The target is to have the input signal is equal to feedback signal, that is output signal. That error is fed to the DC motor. Same arrangement can also be drawn like this: pulse width to voltage converter, control signal, comparator. So comparator means it is nothing but error detector amplifier, error detector, and then there is a error amplifier, then there is a variable output, then it's a motor and whose shaft position is to be controlled, and the shaft is connected to the load, and this shaft is also connected to the gearbox, and this gearbox output is connected to the position sensor, and this position sensor will become the feedback to the comparator. The comparator will calculate the error, that is target position minus feedback position, and that will be treated as error, that is fed to the amplifier, then that is fed to the motor until the difference between the input or the target input and the feedback input is same. Similarly, here also there is another diagram. This is called main winding, this is called control winding, this is control signal, and this is servo amplifier, this is the motor shaft, and this is the actual diagram that you can see. This is the DC motor whose shaft is to be controlled, and this is the control circuit, and this is the potentiometer, and this is the servo horn, and this is the gate train. Let us see its operation. So this is the motor, DC motor, whose shaft position is to be controlled or determined or fixed. In this case, the DC motor output is or shaft is connected to the gear system, and that gear system is connected to the another shaft like this, output shaft, and that output shaft is connected to the potentiometer, and the potentiometer output is treated as feedback signal or reference output signal, and that is fed as input to the detector amplifier or error detector amplifier, and there is an input signal always present, that is also called the target input signal. So once the motor rotates, the motor will have the output shaft position something. In that case, that position is sent as feedback signal to the error amplifier. Then this error amplifier calculates the difference between the feedback output and the input signal, that is reference output signal and the reference input signal, and that error is amplified and then sent as input to the DC motor. And this DC motor, by looking at the error, it will decide whether it is to run clockwise or anti-clockwise direction. Suppose the input signal, that is reference input signal, is more than the feedback signal. In that case, the DC motor rotor rotates in the clockwise direction. This movement of clockwise direction will increase the output shaft feedback, that is potentiometer output, that is also called the feedback output or feedback. So once the output signal value increases, then the error reduces, because the difference between the input signal minus output signal is nothing but error. Once the error reduces, automatically that becomes input to this, and this process continues until this output signal is equal to the input signal, so that error is 0. Then shaft reaches its desired position, then it is called the desired position of the rotor, then motor stops. Coming to the application, it is used in the automatic machine tools, satellite tracking antennas, remote control, airplanes, automatic navigation systems on boats and planes, and anti-aircraft gun control systems. So let me summarize once again about this servo motor. This servo motor is nothing but closed loop system. The aim of this is to fix the shaft position of the motor at a particular place or particular position. For that purpose, the circuit is like this. It will have the motor, and it will have the gear system, and it will also have the potentiometer, that is also called encoder, and the output of the encoder is called the feedback output or reference output, and there is a reference input signal also, and both these are fed to the error detector, and the error detector finds the difference of that, and it will send as input to the DC motor, and based on that input signal, then the motor will decide to move clockwise or anti-clockwise or reduce its speed. Suppose the reference input signal value is more than the feedback output signal, in that case, the motor rotates in the clockwise direction in order to give the better output signal or better feedback signal. So this process continues until a reference output signal value becomes equal to a reference input signal. That means the rotor or shaft of the DC motor attained the desired position. Then the motor stops working. Coming to its applications, automatic machine tools, satellite tracking antennas, remote control aeroplanes, automatic navigation systems on boats and planes, and anti-aircraft gun control systems.